All right, so get started here in a second. So give another second and remember the bit we're picking up with is looking at the graph of this function and trying to figure out what causes these two different presentations, where one of them opens up, the other one opens down. All right, so what is the cause? What is the determining factor that makes either the graph either open up or down? So we said that this is an even function. So what does it mean to be an even function?
Isn't that where the graphics, I think it expands. I can't remember if it narrows or expands, but if the highest if the highest exponent is even, I think it expands.
So if it's even, it means the highest exponent is an even number. Yeah, so that's what we had kind of the very last thing we had discussed last time. So an even function, one of the ways you can tell if it's even is if the end or fringe behavior is the same. So for an even function, at the ends, they both go up or they both go down. An odd function could be like a line, which looks like this, which goes up on one side and down on the other, or a cubic, which looks like this. So it goes down on one side and up on the other. So an even function, we know it's even if both sides go up or both go down. But let's look at what happens where those ends are. So in order to get all the way to the very end of this, what do we know about the x value at the ends?
They go to infinity.
What?
They go to infinity.
Yes, exactly right. Yeah. So if you go to the end on this one, x goes to positive infinity. If you go to the end over here, x goes to negative infinity. So either way, x gets really, really, really big, and you're absolutely right. The further you go, the closer you get to infinity. But let's look at each term up here. So when x is 0, what does this look like?
See,
What?
see.
Yeah. When x is 0, that cancels, that cancels. And so with a small value of x, the determining factor is c. But as x goes to infinity, or really, really big, what takes over? What's the biggest thing here?
X squared. X squared.
Yeah, very good. So as x gets bigger and bigger and bigger, this thing takes over. So because it grows faster than this one. So at the very ends, the behavior is determined by this thing. So A is what determines whether or not this thing opens up or down. If A is greater than 0, it opens up. And A is less than 0, it opens down. Or basically, if A is positive, it will open upward. If A is negative, it will open down. Very, very good. Yeah, so we have this this little quality of parabolas of quadratic functions. Now we're going to look at some transformations, just as a reminder of how we do transformation. So we use a slightly different version of this quadratic equation when we're talking about the graph. So this version is easiest to understand if you're looking at if you're going to play with the numbers. But to look at the graph, we actually want to look at something that's a little bit different. So let's look at the parent function. Y equals x squared. All right. So if you have y equals x squared, let's just fill in some bits here. -2, -0, 1, and 2. If you plug -2 in for x, what does y equal?
4.
4. What about negative?
1.
What?
1.
Very good. 0.
1. Oh wait, 0.
0.
1 and 4.
Very good. All right. So all right. So this graph looks like this, this, and if we kept it going, something like this. Obviously, my graph isn't very symmetric. So, my bad. All right. So this is the parent function. We have a different form of a quadratic that is called the standard form. And it's all about moving or doing transformations of that function. So what were the most basic kinds of transformations? So they were shifts.
Oh.
Yeah, that's fine. But it's just where we move the graph around. We move it up, down, left, right. So Who can remember what we do to move it up or down? What do you have to do? I'm sorry?
Add something to the equation. Or subtract something from the equation.
Kind of. So it's very specific about where you add it or subtract it. So up is y goes to y minus some number. I'm going to say k. And down, y goes to y plus k. This is the weird one where you have to do the opposite of whatever you want to do. So if you want to move the graph up, you're actually going to shift the y values down. Same thing over here. So if you want to go right to left, if you want to go right, x goes to x minus, I'm going to call it h, and left, x goes to x plus h. All right, so if we plug these in and we can kind of assume that moving something down is the same thing as moving it up by a negative number, which I know sounds weird. What we can do is we can create kind of a new form of this equation. So if we apply it to y, we get y minus k. And if we apply it to x, what do we get on the other side?
If you apply what to x?
If you apply the same thing to x, we're going to put in x minus h, but what's it going to look like right here?
X squared minus h.
I'm sorry?
X squared minus h.
Very close. So.
Oh, x squared. Well, wait, go ahead.
So what you just said, if I'm hearing it correctly, was that? Very close. Remember, we have to treat y going to y minus k as a complete removal and insertion. So what we do is x minus h squared, because x,
Oh, yeah.
all of x was being squared, so all of x minus h is squared, but you're very close. And this kind of seems very vague, I'll admit. But these actually have very important roles. So y minus k, whenever we do a transformation, we always resolve for y. So this is the standard form of the quadratic, where h and k are very important values. Because this is just y equals x squared, but you could have something that looks different. You could have, if this is your graph, you could have something that looks like this, where it's the same graph, but it's been moved. But the important part about this standard form is, you don't remember what this thing is called? Starts with a V.
Vertex.
What?
Vertex.
Vertex, yeah. So the little hump, either at the bottom or at the top, if it's upside down, is the vertex. And this is sometimes called the vertex form because the vertex is at the point HK. And this is, I mean, this is something that should kind of feel right, because this is this graph, but shifted around. So the vertex is at the point HK, where H is how far it has moved, is how far X moved, and K is how far Y moved. So this is the, like we said, the vertex form of this standard form equation. So another bit that gets tacked in here is you have to take care of the other possible transformations, which are stretches and squishes. And the way they do that is they just put, let me write it a little bit. Y equals A times that thing. And that takes care of any stretches or squishes that might have been added. So one thing that becomes important is we may get this form, but we need to turn it into something that looks like this. So that's where we're going to spend the rest of our time today, is going from something that looks like that into something that looks like this. I should have done that at the beginning. It is important to know that these are not going to be the same letters. Now there's only one A, C. Okay. So let's take an example. Say we have f of x equals 2 all right. So we need to turn this into something that looks like that. Well, one thing that's immediately helpful is if we know what x minus h squared is after it's been expanded. What is x minus h squared?
x squared plus a squared plus 2x8
So if you actually multiply it out, you actually get 4 terms, and you get 2 of these 2 negative hx's, and you just combine them together. But if you just want to remember that that's what it looks like, then that's fine too. So we need to kind of move this stuff around and get to something that looks like that. We've worked up with this before when we were completing the square. So the first thing you do is you kind of separate things. You want to take the 2 out of the x squared, because there's no number in front over here. So this number is going to be the number that comes out front, period. Even if it's negative or positive, doesn't matter. So we want to turn this into 2 times x squared. What happens if you take the 2 out of the 8? What do you get?
right?
And this plus 7 over here, he kind of immediately jumps out 2. He doesn't care about the 2. So we're mainly going to be playing with the x's over here. So what we need to do is we need to add something onto the end of here so that we can turn it into something that looks like that. So x squared is good. The next term is negative 2h times x. But that has to equal this thing. So if negative 2h equals 4x, then what does h equal?
Negative 2x.
I'm sorry. I should have done it like this. Negative 2h x. But you were, I mean, you sounded right. So what did you say?
Negative 2.
Yeah. So h equals negative 2. So in order to make this thing fit that, we have to add h squared. And we have to subtract h squared, because that's part of the squaring thing. But what is h squared?
4.
4. So this becomes plus 4 minus. Now we have to get this minus 4 out because we only want this part. So this becomes 2x squared plus 4x plus 4 minus 2 times 4, 7. What's 2 times 4?
-8. Well, 8.
8. And what is something minus 8 plus 7?
-1.
Very good. So this is 2. And the way we set this up, when we did this step, when we completed the square, we know that this will always, or this front part, so this part, will always just become x plus or minus half of this. So x plus 2. So this is our completing the square. And this is the form, the vertex form. So where is the vertex of this quadratic?
X is 1.
So this isn't 1.
Oh.
So if you look at it in the other thing, you have a x minus h plus k. So what is k in this equation?
-1.
-1. Very good. And what is h?
Right, -2.
-2. Very good. So that
Yeah,
is
that's
a
X and
potential.
Y. I forgot.
You have a question?
No, I said I forgot that was X and Y. I forgot.
Yeah. So remember the one that's next to the x is going to be the x one. And then because this guy came from over here, he's the y one. But the tripping stone here is often that people want to make this 2 because, or they want to make it positive 2 because it's a +2. So it is important that you look at the sign here, and it's x minus h. So whatever's there has to make it make sense. So let's try this again on slightly simpler one. So first thing we do is we put the number off by himself, and we put this, we take the number that's in front of x squared, and we factor it out of both of these two things. So when we do that, what do we get here?
Minus 6x.
Minus 6x, very good.
Plus 8.
And then minus 8. So the thing that we have to add is half of this number squared. So what's half of that?
3.
3. And what is 3 squared?
9.
Yeah.
Is it always half of that number squared?
It's always half of that squared. So when completing the square, you have x squared plus 2 bx plus c. It's always so because there's this extra 2 here, which is the same as this extra 2 up here, you have to, and you're trying to find b squared, you have to take whatever's here, divide out that 2 to get to b, and then square it. So this thing already has that 2 in it. Good question. But yes, it's always half of this squared. So it's plus 9 and minus 9. But we need to take this extra 9 out. So when we take it out, you have to give it this thing. And that becomes plus 9. So what is 9 minus 8?
Wait, how does it become plus 9?
Good question.
Plus 9.
So if we wanted to get rid of these parentheses altogether, what we would do is we would take this negative and multiply it by everything. And you get negative x squared plus 6x minus 9 plus 9. And then minus 8, right?
Mm-hmm.
Essentially what we're doing is doing this and then saying, all right, now in parentheses, we just want these guys. And what happens if you take a negative out of here? You take a negative out of there, it's negative x squared minus 6x did I do those backwards? No. Plus 9. And then plus 9 minus 8. So it's kind of 2 steps at once. But that's what we do. And that becomes negative x minus 3 squared plus 1. So probably about to be kicked. I'm going to send out an email about the test review stuff on Monday. So keep an eye out